straight line or budget constraint. The knowledge of the concept of budget line, or what is called the budget constraint, is essential for understanding the theory of consumers' equilibrium. As explained above, a higher indifference curve shows a higher level of satisfaction than a lower one. Therefore, a consumer, in his attempt to maximize his satisfaction, will try to reach the highest possible IC, but in his pursuit of buying more and more goods and thus obtaining more and more satisfaction, he has to work under two constraints. First, he has to pay the prices of the goods, and secondly, he has limited money income with which to purchase the goods. So, the two constraints are the prices of the goods and also the money income that he has. Thus, how far he will go in the purchase depends upon the prices of the goods and money income which he has to spend on the goods. As explained above, indifference map represents the consumer's scale of preferences between the two goods. Now, in order to explain consumer's equilibrium, there is also the need for introducing into the indifference curve analysis the budget line, which represents the prices of the goods and consumers money income. Suppose our consumer has got 50 rupees to spend on two goods X and Y. Let price of good in the market be 10 per unit and Y be 5 per unit. If the consumer spends his whole income of rupees 50 on good X, he would buy 5 units of X. Okay, so if he's spending the entire money income that he has of 50 rupees on buying the one good X, he would buy 5 units of that good X because it costs 10. Okay, similarly for Y, and that's how you draw draw the line actually, putting Y as 0 to plot X and putting X as 0 to plot Y. If the straight line joining 5x plus 10y is drawn, we will get what is called the price line or the budget line. This budget line shows all those combinations of two goods which the consumer can buy by spending given income on the two goods at their given prices. A look at figure 8.14 shows that with 50 rupees and the prices of x and y being 10 and 5 respectively, the consumer can buy 10y and 0x, or 8y and 1x, or 6y and 2x, and 4y and 3x. So basically just plot, just put various values in to cause the budget line to be equal to m, which is 50, and you'll get all of these, etc., all of the points that are lying on this very line actually. In other words, he can buy any combination that lies on the budget line with his given money income and given prices of the goods. It can be carefully noted that any combination of the two goods such as H, 5y and 4x, which lies above and outside the given budget line, will be beyond the reach of the consumer. So if you see H, it is beyond the reach, so you cannot buy this because you do not have enough money for H. But any combination lying on the budget line, let's say K, within the budget line, let's say K, can be bought, but you are not optimally using the money income that you have in that case. But if he buys any combination, he will not be spending his income of rupees 50. Thus, with the assumption that whole of the given income is spent on the given goods and given prices for them, the consumer has to choose from all these combinations which lie on the budget line. It is clear from above that budget line graphically shows the budget constraint. Okay, the combinations of commodities lying on the line of the budget line are unattainable because income of consumer is not sufficient to buy these combinations, just like we studied about H. Given consumers' income and prices of the two goods, the combinations of goods lying to the left of the budget line are attainable. That is, the consumer can buy any one of them. It is also important to remember that the intercept OB on the y-axis, okay, OB on the y-axis, this intercept, okay, in figure 8.14 equals the amount of his entire money income M divided by the price PY of the commodity Y, because you're spending that entire money income to buy 10 units of good Y. So basically M by PY. Okay, that's going to be equal to OB. Likewise, the intercept OL on the x-axis measures the total income divided by the price of commodity X. Thus, OL is equal to M, which is the entire money income divided by the price of good X. The budget line can be algebraically shown like this: the price of good X into the quantity of good X plus price of Y into the quantity of good Y that you purchase is going to be equal to M. Okay, that's the budget constraint or the budget line equation. You can also write it like this, the intercept form. Okay, the intercept of the y-axis uh, and px by py, which is the slope, into x, where px py denote the price of x and y respectively, and m stands for money income. The above budget line equation implies that given the money income of the consumer and prices of the two goods, every combination lying on the budget line will cost the same amount of money and therefore be purchased with the given income, because we are going to equate all of these points equal to m, which is basically what we mean by the budget constraint or the budget line equation, right? The budget line can therefore be defined as a set of combination of two commodities that can be purchased if whole of the income is spent on them and its slope is equal to the negative of the price ratio. Okay, like we just saw in the slope intercept form equation of a line. Budget space. It should be carefully understood that the budget equation or the slope intercept form of the budget equation depicted by the budget line 8.14 only describes the budget line and not the budget space. Okay, it's just showing the budget line, the line on which all of those points where you optimally use your money income is present. Okay, a budget space shows all the combinations of the two commodities that can be purchased by spending whole or a part of the given income. If we write this only till a whole, okay, this definition, that is for budget line, but if you include or a part of the given income, then it becomes the definition of a budget space. In other words, budget space represents the opportunity set of the consumer. The opportunity set, which means given this constraint of money that you have, what all can you buy? That is all those combinations of two commodities which he can buy given his budget constraint. Thus, the budget line space implies the set of all combinations of two goods for which income X, that is PXX, and income spent on good Y, which is PYY, must not exceed the given income. Therefore, we algebraically express the budget space as less than equal to greater than equal to M. Okay, sorry, less than equal to M. The budget space has been graphically shown in figure 8.15 as a shaded area. The budget space, the entire area enclosed by the budget line BL and the two axes. Changes in prices and shifts in the budget line. Now, what happens to the budget line if either the prices of goods change or the income changes? Let us first take the case of changes in price of the goods. This is illustrated in figure 8.16. Suppose the budget line in the beginning, which is BL, okay, BL, this one, given certain prices of goods X and Y and certain income. Suppose price of X falls. Okay, so you can buy more of X now. The price of Y and income remaining unchanged. Now, with lower prices of X, the consumer will be able to purchase more quantity of X than before. Let the lower price of X, the given income purchase OL dash of X, which is greater than OL. Okay, so you can come here because you can buy more of good X now with the fall in price. Since price of Y remains the same, there is no change in the quantity purchased of good Y with the same given income, and as a result there will be no shift in point B. Point B is going to remain the same because the price of Y has not changed. Thus, with the fall in price of good X, the consumer's money income at the price of Y remaining constant, the budget line will shift to the right to the new position BL dash. Now, what will happen to the budget line, initial budget line BL? If price of good X rises, the price of good Y and income remaining unaltered. With higher price of good X, the consumer can buy smaller quantities of X, let's say OL double dash, than before. Thus, the rise in price of X, the budget line will shift to the left to the new position BL double dash. Same intuition. Figure 8.17 shows the changes in budget line when price of good Y falls or rises. So, same intuition here, just that the changes are now in the prices of Y. Changes in income and shifts in the budget line. So, we know that if there is a change in the price, it's represented on the same budget line still. Okay, just reminding you of that fact. um, when we're plotting quantity, demand and the price, because if changes in price, we're basically going to be moving along the same um, demand curve. But shifts cause a demand curve to move entirely. Same is going to happen in this case. When there is a change in income, the budget line is going to move entirely. Another question is, what happens to the budget line if income changes when the prices of goods remain the same? Because the constraints here are two: if the prices of the goods change, or if the income of the consumer entirely changes. So if prices are changing of, let's say, one good, then there is a shift like this, like the ones shown in both of these diagrams. But if the income itself is going to change, let's see what happens. The effect of changes in income to the budget line is shown in figure 8.18. Let BL be the initial budget line. Uh, Given certain price of goods and income, if consumers income increase while prices of both goods X and Y remain unaltered, the price line shifts upward. Okay, is going to shift upward because the income is increasing, and is parallel to the original budget line. Why? Because the prices have not changed. This is because with increased income, we are able to purchase proportionately larger quantity of both goods X and Y, of quantity of X than before if whole of the income is spent on X, and proportionately greater quantity of Y than before if the whole of income is spent on good Y. So basically the intercepts were M by Px for here and M by Py for here. So if M is itself increasing, then the whole point is going to increase, right? From B we move to B dash. Same is the intuition for B double dash, L double dash. It is clear from above that the budget line will change if either the prices of goods change or the income of the consumer changes. That the two determinants of budget line are prices and income. Slope of the budget line and prices of two goods. It is also important to remember that the slope of the budget line is equal to the ratio of the prices of the two goods, right? We've already seen this in the slope intercept form of the budget line equation. This can be proved with the aid of 8.14. Suppose that the income of the consumer is M and the given prices of the goods are goods X and Y are Px and Py respectively. The slope of the budget line BL is OB by OL. Okay, the slope is OB by OL, change in Y upon change in X, not change actually, the points intercepts. We intend to prove that the slope is equal to the ratio of the prices of good X and Y, the prices basically. The quantity of good X purchased if whole of the given income M is spent on OL, is therefore OL into PX is equal to M, right? We are spending the entire money income that we have on OL. So with the given price, this is going to be the equation. Now for Y, same intuition, dividing 2 by 1, we can get this OB by OL, what we wanted. The value of OB by OL basically comes out to, reduces to Px by Py, which is what we said in the beginning, that the slope of the budget line is the ratio of the prices of goods X and Y. Let's begin with the entire consumer equilibrium in the next lecture. Thank you.